Hello friends, welcome to Olympiad Mathematics. Now we are going to solve a problem came in Jee Main 2021. This is a problem of complex number, and to solve this problem it needs some special skills, and this is a very conceptual problem. This problem is not a easy one, so please stay tuned till the end to get the solution, to know the solution. Okay, so let's start. The problem says if Z and W are complex numbers such that modulus of ZW equals to 1. That is, Z and W, this is the product of the complex number Z and W, and the modulus of the product is 1. And given that argument of Z minus argument of W equals to 3 pi by 2, then find the argument of 1 minus 2 Z bar W by 1 plus 3 Z bar W. Okay, so look what is given here. Here it is given that argument of Z minus argument of W, argument of Z minus argument of W equals to 3 pi by 2 given here. This information is given, and another information that is given is modulus of ZW equals to 1. Okay, now since argument of Z minus argument W equals to 3 pi by 2, so let us suppose that argument of Z is theta. Okay, then argument of W will be from this we get arguments of W equals to argument of Z minus 3 pi by 2. That means theta minus 3 pi by 2. Okay, now again suppose that modulus of Z equals to R. Now modulus of ZW equals to 1 implies that modulus of Z1 Z2 is modulus Z1 times modulus Z2. So this can be written as modulus Z into modulus W. This is equals to 1. Okay, so my friend, we may read this as omega also, okay, but we are pronouncing this as W to make it easy. Okay, so modulus of Z times modulus of W equals to 1. This means here is given, here we have laid that mod Z equals to R, that means R times mod W equals to 1, and that means modulus of W equals to 1 over R. So now we can write any complex number in modulus amplitude form. Okay, so let us write Z in modulus amplitude form. Given that modulus of Z equals to R and argument of Z equals to theta, so we can write Z equals to R e to the power I theta. And similarly we have that modulus of W equals to 1 by R and argument W equals to theta minus 3 pi by 2. That is, we can write W equals to 1 over R e to the power I times theta minus pi by 2. Sorry, theta minus 3 pi by 2. Okay, now look, we have to find argument of this. Okay, so what now? So if Z is this, so look here Z bar is given. So what will be Z bar? Just Z bar means in place of I we will write minus I. So replace I by minus I. Replacing I by minus I, we get Z bar equals to R e to the power minus I theta. Okay, so now let us write this expression 1 minus 2 Z bar W by 1 plus 3 Z bar W. Okay, now let us write this expression clearly. So 1 minus 2 times Z bar means R e to the power minus I theta into W means 1 by R e to the power I into theta minus 3 pi by 2. Similarly, the denominator gives 1 plus 3 times Z bar means this R e to the power minus I theta times W is 1 over R e to the power I times theta minus 3 pi by 2. Okay, so now look, let us write this. So this R and R cancel out. So now we have 1 minus 2, look, e to the power minus I theta multiplied by e to the power I into theta minus 3 pi by 2. So this is multiplication of multiplication, that means the exponential will be added, the powers will be added. So we can write this at e to the power I times minus theta plus theta minus 3 pi by 2. Similarly, the denominator also, this R and R cancel out. We have 1 plus 3 times e to the power I into minus theta plus theta minus 3 pi by 2. So what we have now? Look, now we have 1 minus 2 times e to the power, look, minus theta and plus theta cancel out. That means e to the power I times minus 3 pi by 2, that is minus I into 3 pi by 2. Similarly, the denominator gives 1 plus 3 times, here also plus theta minus theta cancel out. We have 3 times e to the power minus I into minus 3 pi by 2, that is minus I into 3 pi by 2. Okay, so now let us find what is e to the power minus I into 3 pi by 2. Let us calculate that. Now we are doing the calculation here. E to the power minus I into 3 pi by 2. Okay, so this is cos 3 pi by 2 plus sin 3 pi by 2. Okay, that means we can write this as this, minus I, sorry, this will be cos 3 pi by 2 minus I sin 3 pi by 2. Okay, now cos 3 pi by 2, this is cos 3 pi by 2, what? This is 0. Okay, minus I sin 3 pi by 2 can be written as sin pi plus pi by 2, that is minus I times sin pi plus pi by 2 will be key minus sin pi by 2. Okay, look, sin, so here we write minus I, and sin pi plus pi by 2 is minus sin pi by 2. Okay, so minus minus plus I sin pi by 2, and sin pi by 2 is 1. So this is basically I times 1 equals to I. So e to the power minus I into 3 pi by 2 is equals to I. So we can write this expression as 1 minus 2i by 1 plus 3i. Okay, now we have to, now what will we do? Just we will multiply the expression numerator and denominator by 1 minus 3i. So 1 minus 2i times 1 minus 3i, and the denominator becomes 1 plus 3i times 1 minus 3i. Okay, so this is equals to, now let us multiply 1 minus 3i minus 2i and minus minus plus 6i square, and the denominator gives 1 minus 3i square. Okay, now this means 1 and 6i square is minus 6, that is minus 5. 1 minus 6 is minus 5, and minus 3i minus 2i is minus 5, and the denominator becomes 1 plus 9. Okay, so this will be 3i square, I square is minus 1, so minus minus this will be plus, so 1 plus 9 is 10. That means minus 5 by 10, that is minus 1 over 2, minus 5 by 10, that is I times 1 over 2. So basically this is the complex number, minus half minus I into half. Okay, so look carefully now. We can write this as 1 minus 2 z bar w by 1 plus 3 z bar w equals to minus half minus I into half. So argument of this is basically we have to find the argument of this. So we have to now find the argument of this. Now again, we can write any complex number in the modulus argument form. So now let us suppose that the modulus of this complex number, now we can find actually the modulus. Look, here we have the complex number minus half minus I times half. Okay. So what is the modulus of this complex number? Let us find the modulus. So mod of this is root minus half square plus minus half square. So that is equals to 1 over 4 plus 1 over 4, that is equals to 2 over 4, that is equals to root 1 over 2 equals to 1 by root 2. So modulus of this complex number is 1 over root 2. Okay. Now let us suppose that amplitude of this complex number is phi. Okay, then we can write this complex number minus half into I over I times half. We can write this complex number in modulus amplitude form. So the modulus is 1 over root 2 and amplitude is phi. So 1 over root 2 e to the power I phi. That is 1 over root 2 cos phi plus I sin phi. Now comparing the real and imaginary parts in both sides, we get 1 over root 2 cos phi. This is equals to minus half. This is the real part, and the imaginary part is here 1 over root 2 sin phi, and that is equals to imaginary part of this, that is minus half. Okay, now so this implies that cos phi is equals to, multiply this root side in the right hand side, so 1 over 2 into root 2, that is minus 1 over root 2. So this is cos phi. Now that means minus cos 1 over root 2 means pi by 4. So basically cos phi is this. Cos phi is minus cos pi by 4. Similarly, if we do this, we will get sin phi equals to minus 1 over root 2 into minus 1 over 2 times root 2. That means sin phi equals to minus 1 over root 2. That means minus sin pi by 4. So sin phi also is equals to minus sin pi by 4. Look, here is cos pi by 4. Minus cos pi by 4, and here is minus sin pi by 4. So we can write cos pi equals to cos pi plus pi by 4. Minus cos pi by 4 can be written as cos pi plus pi by 4. Similarly, minus sin pi by 4 also can be written as sin pi plus pi by 4. Okay, so now we have cos pi equals to cos 5 pi by 4, and here we have sin pi equals to sin 5 pi by 4. Look, in both the equations we have same cos. This means pi equals to 5 pi by 4 from this, and this means pi equals to 5 pi by 4. So basically we have got that pi equals to 5 pi by 4. But what was our phi? Phi was, look, here we have assumed that phi is the amplitude of this complex number. Okay, but amplitude, so this is basically amplitude of this complex number, minus half minus I times half. So let us rename this complex number as Z2. Okay, so this is amplitude of a complex number. Okay, so amplitude of Z2 is 5 pi by 4. Okay, look, but one thing is amplitude of Z2. But one thing you should know, that amplitude of a complex number theta must remain in between minus pi and pi. But this is greater than pi, so this cannot be the amplitude. So what will be the amplitude? Amplitude is theta plus m. What is m? M's value will be 0, 2 pi or minus 2 pi. Okay, so here if we add 2 pi, it will again increase. but it is already greater than pi, so we have to subtract 2 pi. So the amplitude will be 5 pi by 4 minus 2 pi. That means 4 5 pi minus 8 pi, that is equals to minus 3 pi by 4. So the amplitude of the complex number Z2 is minus 3 pi by 4. Look, this theta, this 3 pi minus 3 pi by 4 lies between minus pi and pi. So this is the amplitude. So amplitude of this complex number is minus 3 pi by 4. What is the complex number? Z2. Now what is Z2? Z2 is this complex number, and this complex number is the simplified form of this complex number. Okay, so argument of this complex number is minus 3 pi by 4. So this was what we needed to find. Look, find the argument of this. So argument of this is minus 3 pi by 4. So thank you friends. So this was the answer, my friends. Hope you have enjoyed the video. Please subscribe the channel and don't forget to share the video with your friends. This was a very conceptual and tricky problem. Came in this year's Jee Main examination. Hope you have enjoyed the problem. Stay tuned with us because we will come back shortly with this kind of video again. And if you have any query regarding this problem, please let me know in the comment section. And if you want to ask me any question, you may let me know in the comment section. So thank you friends.